Good afternoon, ladies and gentlemen. My name is Hanifah Syahirah Vedy with NPM 21110110005, majoring of Management of International Class. So for today, I will do a presentation about size dispersion and also the case study of the size dispersion itself. This is the table of contents for my today's presentation. The first is about the size dispersion, so I will explain about it in general. The second is about the type of size dispersion, and the third is the formula of size dispersion, and the fourth, the study case of size dispersion, which I take now as my study case. So this is the first table of contents is about the size dispersion. So we can say that size dispersion is a parameter used to determine the magnitude of the deviation from the data's average value. So the spread of the size dispersion itself can indicate about how far a value deviates from its mean. So we can conclude that the smaller the spread, the greater the deviation. So this is the second table of contents about the type of size dispersion. The first type is the average is the same and distribution is the same. We can see about the graph here and it's really experimenting the meaning. And the second type is different mean with different distribution. And the third type is different mean with the same distribution. So there are three types of size dispersion. So this is the formula of the size dispersion. I can say this is a quite basic formula of the size dispersion. The first is about to knowing the range. So to know about the range, we need to calculate about the highest value minus the lowest value. So we need to know how much is the highest value and how much is the lowest value so we can get the range. And the second formula is about average deviation. So it's the simple is MD. So MD equals to delta x minus x squared divided by n. And about the variance is, we can say it's O. We can search it by delta x minus mu squared divided by n. And for the standard deviation, we can calculate it by O equal to square equal to root of delta x minus mu squared divided by n. So I can say that this is a quite basic of formula size dispersion. And this is the size of the relative spread. The first is about range coefficient. Its symbol is KR, and the B is the coefficient of standard deviation is KMD, and the C is coefficient standard deviation or KSD. So this is my study case, like what I told you before. I take my study case from the Chanel sales bag. So we know that Chanel, a French luxury company, in this case, wants to calculate the range, the standard deviation, and the relative coefficient of bag sales from Southeast Asia countries in order to maintain their sales in Southeast Asia. So the following table on the right side are the sales in several cities in Southeast Asia in August 2022. So this is the name of the country and the number of bag sales. In Indonesia, there are 321 bag sales in August 2020, Malaysia 245, and Singapore 425, and Thailand 198, and the Philippines 142 bag sales, and the Cambodia 138, and the Vietnam is 78. So we can conclude that there are 7 data of country about the number of bag sales in Southeast Asia for the August 2020 and 22. So the first that they want to know is about the range. So this is the range formula. Like I have told you before, to know about the range, we need to know about the highest and the lowest value. So we can see here that the value from Singapore is the highest. It's 425, and the lowest came from Vietnam, 78 here. So we can just calculate it by minus the highest minus the lowest. So you got 347 as the range of our case, Chanel bag sales. And the second thing that the channel company want to know is about the standard deviation. So for calculating the standard deviation, we need to know about the mu first. So the mu, for searching about the mu, we need to know the total of the x. So this one is the number of the x, and the total is 1547 divided by n. So the n is the total, how many data that you have. So in this case, you have 7. So we can just calculate it by 1547 divided by 7. So we get 221 as our mu. And after that, from this table, from this data, we can search for the x minus the mu, because the mu that we have is 221 and the number here from Indonesia 221. So we get minus 100, and for 245 we get minus 24, minus 204, plus 23, plus 79, plus 88, 83, and plus 143. And this is the x minus mu square. So we can calculate it by this in the middle, and we can make it square. So we get 10,576, 41,616, and 521, 6,241, 6,088, 889, and this one is 20,449. So the calculation of, or the total of x minus mu square is 86,300. So we can calculate it by making the root of delta x minus mu square, or 86,300 divided by n that we have, that is 7. So the answer of this standard deviation is 111.0341. The third thing that they want to know, the channel company want to know, is about the relative coefficient. So for searching about the relative coefficient, we need to know about the O, the standard deviation here, and divided it by the mu. The mu here is 221 times 100%. So we get the answer of 50.241%. So we have completed to answer the things that the channel company wants to know is about the range, the standard deviation, and the relative coefficient by doing this step. So this is the end of my presentation. I would like to say sorry if I made a mistake during my presentation, and I would like to say thank you for listening about my presentation till the end. Wassalamualaikum warahmatullahi wabarakatuh.